Geometry Trig Honors, Lesson 7.4, Trigonometric Identities. It's safe to say you are not in Kansas anymore. This is some tricky stuff, but it's like a puzzle. If you are a puzzle person and you like to solve ambiguous problems, you're going to have some fun here. If you like math to be laid out nice and clean and neat, you're going to go crazy. Quotient identities, tangent and cotangent. Tangent sine over cosine, cotangent is cosine over sine. Reciprocal identities, and these are all things you need to know when we go through and prove trig identities. Why are we proving trig identities? It'll be used a lot in calculus, and I can finally tell you I know that firsthand. Reciprocal identities are the three, and the reason we write these down is they do come in handy. Quite often I will write down everything in terms of sine and cosine, just to make it a lot simpler to look through. Pythagorean identities pop up. The one you really need to know is the first one. Gets used often, quite often. The other two are good to know too. They get used, and they can save some steps, so it's kind of nice to have them in your hip pocket. And then the even-odd identities, which are a little nastiness that we can throw in there. Sine of negative theta equals negative sine of theta. Cosine of negative theta equals cosine of theta. I think that's all you're going to need to know. But while we're at it, tangent of negative theta equals negative tangent of theta, and secant of negative theta equals secant of theta. I'd like to note that I really try to be fairly neat with my handwriting in these videos, and you're probably saying, you got to be kidding me looking at what I just wrote. Well, when we're doing trig identities, there's so much to write that it's definitely going to be abbreviated, so just so you're aware. Let's put cotangent up here. And cotangent's an odd function too. And then I think we only have cosecant left. And cosecant, of course, goes with sine, so it's got to be an odd function too. So the only even functions are cosine and secant, where you plug in a negative and you get the positive out, so on and so on. So what do we do with all these things? Well, we just simplify. So here's a typical rule. And I shouldn't say rules, but a solving technique. Make everything sine and cosine. I'll even forget to write my theta sometimes. I'll try not to do that here. So this is cosine of theta over sine of theta over 1 over sine of theta. Now, I know I can cancel those. If you're a person who's stuck on that, you better get that down fast. It's one small step of what will be a 32-step problem. If you really need to write it out, just remember this is like a big divided sign. So we're dividing by the bottom, so we flip it, multiply by the reciprocal. So this is just an example of simplifying things. We had two terms with cotangent, cosecant. Now we have one term with just cosine. A little bit easier. People look at this and go, well, there's cosine and sine. Why would you change it? Two reasons. One, you're going to have to see this trick. And number two, we'd rather have nothing with an addition in the denominator. And we're going to multiply by the conjugate because the first Pythagorean identity makes that pretty handy. And I am not going to distribute the top, even though every urge in my body tells me I should. I'm going to change the order for no really good reason. I just like to. In the bottom, I get 1 minus sine squared theta. Well, if we remember, and I'm really hoping I never have to write this down again, We can solve this for cosine, and we get 1 minus sine squared theta equals cosine squared theta. So up here we get 1 minus sine of theta times cosine of theta over cosine squared theta. Cancel, cancel. 1 minus sine of theta over cosine of theta. Like to reemphasize, you might say, well, I don't really see that being all that much simpler, but it is. It's gotten rid of the addition on the bottom. It's definitely something that's easier to handle. So this is just going to keep going and going and going. So as I have said before, I really hope you're good at fractions. I'm going to multiply over here by cosine of u over cosine of u, and over here by sine of u over sine of u. It gives me a common denominator. By the way, I'm flying completely by the seat of my pants right now. I really am not sure what I'm doing. This one I'm gonna blast out and see where it takes me. Cosine of u plus sine of u cosine of u. A little bit OCD-ish here. Cotangent is cosine over sine. When I multiply through by sine, I'll lose the denominator and be left with cosine of u. Nothing's going to happen here. I'm just going to get a minus sine of u cosine of u. So the number one question I get is, well, how did you know to do that? And the answer is, I don't know. I'm just playing. Sine of u positive cosine u, sine of u cosine u negative. Going to cancel. And I am left with 2 cosine of u over sine of u cosine of u. Hey, look at that. These cancel. I'm left with 2 over sine of u, which, now as things get really weird, they prefer not to leave anything on the bottom if they can help it, even though I did in the previous problem. They'll typically write this answer, although I'll accept either, as 2 cosecant of u. Looks so neat and tidy, they just feel all warm and fuzzy about it. My textbooks actually left it like this, so I'll take it either way. And let's factor the bottom. I think I should change the top to something. I think I should factor the top too. You know what? I'll leave it. Let's see if it pops up, because I know how to factor that real fast. Let's take out tangent of v. My v's have a little curly q. Here's a big v. People tell me it looks like a u. Well, tough. Get used to it, because that's how I do it. Sine of v minus 1. Hey, I think I'll factor the top. Sine of v plus 1. Sine of v minus 1. Hey, they cancel. Cool. Equals sine of v minus, plus 1 over tangent of v. I'm going to call it done there. I could actually take the tangent, change it to sine of cosine, flip the cosine up top, see if that takes me anywhere. Good enough. So what are some of those tricks that we use there? I already mentioned the sine cosine trick, factoring, multiplying by conjugate, so on and so on and so on. Now, the simplifying is just the warm-up round. You're actually going to be proving things are identities, and that's a lot better because you know where you're going, but it's a lot harder because problems are much more complex. The good news is if you're given a problem by a teacher who says, prove that it's an identity or prove that it isn't, immediately graph both sides. And I'm not going to do it here, but throw this in your calculator, make sure your calculator's in radians, throw a second equation here, and they better be the same. If they're not, then, just say, hey, they're not, and tell your teacher you're a genius and you figured it out. Now, we only want to work on one side if we can. Sometimes we do have to bring the second side into play, but we usually work on the more complicated side. So I'm just going to write this side here. That's 1 over sine of theta times sine of theta over cosine of theta. They cancel, and I put a check mark as in 1 over cosine of secant. I know I'm done. If you have some evil teacher someday who wants to see this, actually they might want to see all of it. Oh, well, therefore secant of theta equals secant of theta. Fine. go ahead and go that extra mile for them, but I'm not that person. Once I see 1 over cosine, I know that equals secant. I'm smart enough to be able to grade it. So when we mean verify, we are saying establish. Sine squared of negative theta of cosine squared of negative theta is 1. We're pretty much done there. I mean, if you want to write it out, and I don't know why they'd give us a problem like this, but if you want to write it out and say, well, I know that sine of negative theta is negative sine of theta. Oh, by the way, we're squaring it, plus cosine of negative theta is just cosine of theta, and we're squaring that. Well, the negative squares away, and you just end up with 1. Go right ahead, knock yourself out if you feel the need to do more work. I'm bothered by all these negatives. I don't like them. Ooh, but they're subtracting now, so be careful instead of plussing. That could be tricky. So I get negative, oops. I already know how this is going to turn out. We're going to end up getting rid of the negative. I just showed you why a second ago. And here I will get actually something slightly different because it doesn't get squared away. This is making me nervous. I can factor the top, sine of theta plus cosine of theta, sine of theta minus cosine of theta. Those don't look like the bottom. Oh, the humanity, what shall I do? Hey, what if I factor out a negative? Well, now these cancel, and I'm left with distribute the negative. I shouldn't put an equals because that means I'm working on the other side. Let's throw the negative up top and just leave it like this for now. Minus cosine of theta, negative sine of theta plus cosine of theta. Woohoo! Hey, it's not in the right order. I don't care. Looks good. When I teach this, I get a lot of whining from students. Oh, you're so good at this. How did you get so good at this? I did like 700 problems over the last, that's an exaggeration. I did probably about 40 or 50 problems over the last couple of days. That's how you're going to get good at this. It is pure practice, and it's hard. It's challenging. A lot of people who've breezed through a lot of math suddenly go, this is really hard. I don't like this. Oh, yeah, get used to it. Let's multiply the bottom by the conjugate. Why not the top? Well, maybe that would work, but you remember, we want to get rid of the fraction on the bottom, the plus or minus on the bottom. So let's multiply by the conjugate. See what happens. Top's 1 plus tangent of u. It's going to get a little weird, so bear with me. Bottom would be 1 minus cotangent squared u, which, I'll throw that one out here. Cotangent squared plus 1 equals cosecant squared u. That doesn't really help me, does it? Maybe I shouldn't have multiplied by the conjugate. I could cheat and look at my book, but I don't mind being wrong. Yeah, I'm going to get rid of it. Oh my goodness, the notes are all screwed up. Yeah, this is what happens, people. It's not the end of the world. Let's go with sine and cosine. Sine of u over cosine of u. 1 plus cosine of u over sine of u. I'm going to go with common denominators, top and bottom. Cosine of u plus sine of u over cosine of u. Sine of u plus cosine of u. Ding ding, over sine of u. Cancel, cancel. I get flip and multiply. Sine of u over cosine of u. Check. I just did about 3 or 4 neat math things in there. I am sure I blew some people away. Get ready to rumble. That's what it's all about. I don't feel like doing this. Can I cheat a little bit here? I'd love to cheat if I can. Cosine over 1 plus sine was 1 minus sine over cosine. Darn. Gotta do it all. That's alright though. Sine of theta, 1 minus cosine of theta. I'm going to show you a shortcut. I'll do it out here. The denominator is this. But since these things are really long, and after a while you get kind of tired of it, you're going to start recognizing the shortcuts. So this is sine squared of theta. cancel, cancel. 1 plus cosine of theta over sine of theta. 1, the negative cancels, so we get 2 over sine of theta. Check, we're done. So in the future, you may see me shortcut that, so I don't want to spend years on it. So, 2 to go. Last time I tried this, I tried something fancy. You know what? Let's just do the sine and cosine thing again. No, this is something I've seen before. You know what? I'm going to do this off to the side. I don't remember what happens to it because I don't have the problem top of my hand. I want to say this is, no, don't remember. So there's the top of the fraction. Oh, let's go with the common denominator. Sine of v, oh, there it is. It's going to be 1 over this thing. Cosine of v over cosine of v equals, again, I would not write this out in the future. I'd know where I'm going with this. Top's 1, sine squared plus cosine squared. Let's come on back. So the top is 1 over sine of v cosine of v, and the bottom is 1 over cosine of v sine of v. Cool. Done. I should run up and do this again. I'm going to work on the right side now. I don't think I have worked on the right side. 1 minus sine of theta. Now, I warned you I was going to do this, so I'm now going to do it. In my head, I know the bottom becomes 1 minus sine squared theta. And I know that 1 minus sine squared theta is cosine squared theta. So the left side is cosine of theta, 1 plus sine of theta. And I could actually literally put a check mark right there, but that would be being lazy. Cosine squared theta. See ya, see ya. Check mark. Ooh, copied it wrong. Naughty me. And that's it. I've already given you all my thoughts. I've written them down here to make it simpler. The part that's not here is that you really need to practice these. You need to get good at them. They really develop some great logic skills, so this is beyond trig and mathematics. This is the, wow, I'm faced with a problem in real life, and I just kind of shut down and give up. As opposed to with these problems, I really worked hard, and I learned something, and I got better at it. It's a skill I can apply somewhere else in life, anywhere else, everywhere else in life. There's all my stuff. Sums and difference quotient, single quotient. I don't even know what the heck that means. But like I say, get rid of the pluses and minuses and go for it from there. But sometimes you'll get lost in the problem. That's what that's talking about. So just keep hacking away, stop, take a breath, walk away, do another problem, come back. Oh, that's right, I missed it. It's obvious. It's right there. And that is about it. As always, happy mathing.